So this is the slide deck that accompanies the practical that we're doing in this first session, which is, I mean, you'll get used to me rubbish like cliches and things like that, but it's LED the way or LED the way, your first circuits. So we're going to do some bash commands, which I'll come to in a minute. I'll actually come back to this slide in a minute. But essentially, when we've installed our operating system, we're going to install, just to show you a little bit of how the Linux operating system and bash commands work. Just about listing files, making directories. But this one, the actual power you've got, we're going to install a program called fritzing, which is how we can actually do our circuits and our breadboarding and things like that in a diagram way. So we've got actually a record of what it is we've done, so we can come back and do it again at a later date. But before we do that, I'm going to briefly just do a whistle-stop tour of operating systems on the Raspberry Pi, because I mean this is a massive thing. We can't do this in the session because we'd all just be sat there watching a screen for an hour while it burns the image to an SD card or a USB stick, whatever. So what we do on this, we have to choose our device, which device we've got to going to put our operating system on. So it gives you a choice of doing that. You've got Raspberry Pi. You've even got down to the old legacy ones and things like that. Even the Raspberry Pi one, you can even still get operating systems for. But you choose your device. But it is absolutely amazing the amount of operating systems there are out there for this. There's lots of other programs out there to do this, but I just think the Raspberry Pi Foundation have done a really good job of pulling all the best ones together into this imaging software. So yeah, so let's go back. It's actually called, this is the Raspberry Pi Imager. So it burns what's called an image. Operating systems are burned as an image to a storage device that then, when it starts up, the operating system is found and then puts the operating system on that device. So we chose Raspberry Pi 5. You can choose the operating system with a 32-bit, 64-bit, etc., or any other operating system, because there's literally loads of people use these as media centers. So you can just set this up as like a Cordia media center, put it on the back of your telly, connect some external hard drive, and you've got a full-on media center on the back of your, TV on your wall or wherever you've got it. There's all sorts you can do to do with media. Also, a quite common one is what they call, like a retro Piecade. So you can put lots and lots of games on it, old games, like as if you've got like asteroids and Scramble and Space Invaders. But you can literally put thousands of games on one Pi and like make a Raspberry Pi card. Very, very, very popular as well, that one. The other one, this is also really, really popular come up, is digital signage. So you can actually program your Raspberry Pi to run through a massive series of digital signage on big screens, big displays and things like that. Literally very big displays as well. 3D printing, which is also a thing. You can run the entire software for 3D printing attached to your device, attached to your 3D printing device. That's all available on there as well. The one that I've used it for is a Home Assistant. So you can set up, like, it acts as like a server and puts all your Home Assistant devices on there, cameras, sensors, things like for light sensors for opening and shutting curtains, all sorts of stuff like that. I've used that personally myself at my old father's house. So this is the project that we're going to do once we've had a play about it before and we've installed. So this picture's done with fritzing. So if we just go back to slide 2, I'll just show you that. So if we just run this command sudo in the terminal, so we need to open the terminal, which is the little black screen with a little blinky cursor, and we just type in the sudo apt-get install fritzing, where it goes to the apt repository and pulls in this program called fritzing. The best way to install software. It's absolutely fantastic, Linux, for that. It was a game changer for me. Like, I've been solely using Linux pretty much now for well over 10 years. So this is a map of our GPIO pins. It tells you what numbers they have on. It tells you also what they do. But we can program these pins to do things. So what we're going to do now is we're going to set up our Raspberry Pi with our breadboard with a little 200, I think it's a 220 ohm resistor, making sure our resistor goes across. If we do it in line, it doesn't fully resist because the copper wire still goes up. You can actually see where the electric is conducted on that because it lights up green when you do it in fritzing. And just explaining a little bit about an LED, which is a light emitting diode. So we've got a short leg, which is a cathode, and that's the out route. So that's the negative. And we've got an anode, which is the longer leg. There's always a longer leg, and that's the anode, and that's the positive. So like the electricity goes in through the anode and out through the cathode. Now there is a flat edge as well, if you look at the edge of them, but I don't know if it's my eyesight as I'm getting older or whether that, but I can never seem to see that flat edge. So blessed are the long legs and the short legs. If it doesn't work, I've get this a lot at workshops, people do put them back to front. It doesn't do any damage, just turn it round and your light will work. So this is just a little bit of Python code. So in this one, we're going to open Thonny, which is a Python IDE, integrated development environment. There's lots of other integrated development environments you can use, but Thonny is the one that's already on there out of the box. So we just create the little file that we'll save, which will be blinky.py, and we'll just put this in it. So what this is doing is importing these libraries, GPIO 0, it's importing LED, and from one called time, it's importing sleep. So essentially, it's saying we're declaring a variable on pin 17 called red. It doesn't matter what you can call it what you want, whatever your LEDs, you have to call it the same here. So it's saying while true, just turn it on. But then it uses this sleep function where it turns it off every second. So that's that little program. So you just see how Python's making that work, and it'll just blink through. An easier way and a quicker way to do it is using the pause function. So the same again, this time we're pulling in LED, and from signal, we're importing a thing called pause. So what it's doing there is on that same pin, we've declared a variable called red, and red's going to blink, and it's going to use the pause function. And we can also use this other one, which is PWM, which stands for pulse wave modulation. So the same again. So what we're going to do here, we're going to import pulse wave modulation LED, and we're going to use the sleep function again. But what this one's going to do is this one's going to do it in gradual steps. So it's not on, then it's going to be half brightness, then full brightness in between each sleep cycle. It's just worth trying so you can see how the code works. Something that we get at a lot of workshops is that you've got to stop the program running before you start the next one. A lot of people say, I've put this in, but it's doing exactly the same as the one before. So it's the old program still running. So if you just stop it running in your Python console that's running from Thonny. And then the other one is we can just literally use the pause function with the pulse wave modulation as well. And that one's a bit like, like a pulse where it's just like in and out, like a breathing lung. The light just comes lighter and fades like a breathing lung. So, that's pretty good stuff just to be getting going on with, getting you understanding just them basic circuits. When I say homework, I mean, it's just places that you can go and do some research and things like that. So there's loads and loads of good projects on here. As I showed last week, at the end of the 4-week session, there is a prize of a solder kit crystal set radio for the best project that comes out. So this is just researching and doing a short paragraph, what project you're thinking of building or what you're liking to build. Remember, don't be too ambitious. You've only got essentially 6 hours to do this. We've got 3 2-hour sessions left. I mean, you can do it in your own time and things, but just don't be too ambitious. Just be realistic, but you can be ambitious, and we'll see whether it's doable or not doable, because we can only do it with what's in our parts bin as well. And finally, for those people that do want to get any of this stuff, for the Raspberry Pi, I always use CPC Farnell to get most of my stuff, to be honest with you. There are other shops like Pi Marone is really good, the Pi Hut, the Arduino store, but I tend to get all my Arduino stuff, which is like copy Arduino. It's not snide or illegal. Remember, Arduino and all this is open hardware, so it's all done on an open hardware license. So you can make all this stuff. But I use banggood.com. It takes a little bit of time to get here, but it's cheap. So I hope this helps to jog your memory of the people that attended and fills people in that didn't attend that are coming to the next session. Thanks very much.